I remember. here, let some people in the room, and come back over here. So now I'm in my project folder, our class folder, and I'll go into this topic 3 Instagram folder, type ls, and then this Flask web folder right up here. Want to go in there, cd Flask web, type ls, and we have these 3 files right here that are the files from the homework. I want to make both my windows be the same here, so I will do that up here as well. Flask web, type ls, and we're in the same location for both of these terminals. One last thing to do before we get started in earnest here is to clean up my screen a little bit. It's always nice to have a clean working environment. And the first thing that is annoying to me is that my prompt now is really, really large here because I'm in this very deeply nested subfolder right here. And it turns out there's this variable called PS1 inside of the shell. This is, again, a POSIX standard variable, works on Mac, Linux, whatever terminal system you're using. And PS1 describes what the format of your prompt is going to be. I'm going to change my prompt to be just a $, like this, $space, so that it's not going to take up all of the space up there. And I'll do this on both ones. PS1 equals like this, and reset down here. And now we're still in this very deeply nested folder down here, but the screen's not as cluttered. Any questions about the problem setup here? Yes. I'm not sharing my screen on Zoom. That is a disaster. I apologize for that. I thought I did this already. Okay. Now, hopefully, that is being shared, and it will be recorded for us as well. Thank you for that. Any other questions about what the problem setup is right here, what we're doing? Okay, so again, we're using Docker to Docker here to deploy our Flask application, and so I ran Docker PS down here in this bottom window just so that we could see what systems are running. I have my screen zoomed in pretty detailed right here, so it's a little bit harder to read this Docker PS command output because it's all bleeding over onto multiple lines. But we can see that there are two containers down here running. I'm going to stop both of those containers. Docker stop, and then the container ID here, like that. And then this other one. One of the things, anytime you see these hash values in anywhere on your system, any tool that uses hash values, so Docker and Git both use hash, you don't have to type in the complete hash value in order to reference it. You can just type in a small amount so that it becomes unique, and then the tool will sort of fill in the rest of that. So instead of typing this full hash right here, I can just type in something like B8B. That'll refer to this container right here, and we'll be able to stop it with just that shorter hash. This one, for whatever reason, is taking a little bit longer to stop. Up here, I type Docker PS. We can see that I've stopped this top one. Now it's finally stopped that bottom one down here, and we have no containers running. One of the first steps in your homework was doing this Docker build dot like this. And when you did that, then you probably got an error message that looks something like this, where the build command did not complete. It did not finish. On the top window up here, I'm going to open up my Docker file, and we'll talk about exactly why that did not finish. So vim Docker file up at the top, and then down here is actually a terminal window still. Highly recommend whenever you're working on anything in this class, but especially this the homeworks related to Docker for due today and due next week, that you have 2 terminal windows open so that you can always see like what the error messages are down here and your code up in the other window. It's much more efficient to be able to see both things at once rather than having to be switching back and forth between the 2 different terminal windows many times. And so we talked about the from command last time, that this is downloading this Ubuntu image. Again, an image is like a pattern that describes what's going to go into a container, but it is not a container itself. This is the outline for how to build a container. We didn't talk about the maintainer line at all, but this is just sort of machine readable documentation for our image that we're building, and telling who the maintainer is. So I put my name in right here. Everything else is just copied and pasted so far from the tutorial though. These run commands, these are literally running these commands inside of the shell down there. So, or inside the shell, inside of a container to build this image. The apt-get is a command inside of Ubuntu for installing things. And we've seen before that we can use the and the backslash to sort of link these commands together. There's a very common pattern to use in Docker files is if you have multiple commands that you want to run at once, then you chain them together with the and, so that this command down here only runs if this command up here was successful. And we use the backslash over here to make this equivalent to a single line, and just makes things a little bit more readable. Later on in this class, we will have run commands that are like 20 or 30 lines long because they have so many commands down here being chained together, and it's just a standard thing to do. We didn't talk yet about this copy command. This is copying this requirements.txt file from the Lambda server over to this location on the image. And so we're gonna verify that this command is in fact happening. We'll see what it's going to do here next. Down here on the bottom of my screen, I'm gonna talk about this output, and then we'll see how that relates to the Docker file so far. So here's the line where I ran docker build dot like this, and scrolling down, we can see that there's 9 steps in this Docker file corresponding to the 9 different commands up here. Most of these happen very fast, like this maintainer line does basically nothing, so it happens very fast. The first time you ran something like this get update command, it would take a long time, but you can see here it says it's using cache, so it happened very fast this time. And I want to come down here to this copy line right here. You'll notice that at the end of each of these steps, there's one of these hash values right here. These hash values refer to what the actual the hash of the image that's been created so far. So I can use any of these hash values to start a container from this location. And I'm going to, let's do this hash right here because this is the one right before our failure down here. I'm going to use this hash value right here, and I'll type docker run -it and then that hash value. And if I do that, you can see that it puts me inside of a Docker container right here in this /app folder. I'm in the /app folder because the workdir command right here, this is like setting the present working directory. It sets the working directory to /app right here. This is the working directory /app. And if I type ls right here, we can see there's this requirements.txt file, which was moved over by this copy command from the Lambda server to the image. And so I'm inside of this image that was created up to this point. And the next command down here, this run pip install, is this thing that was giving me this error message down here. Any questions about where I'm at so far? What's going on? Is this all making sense, seeming familiar from what you all did, saw in the homework? A lot of blank stares, everybody's totally lost. A couple thumbs up now. Okay. I'm going to go through a debugging procedure, or this is the first step of a very useful debugging procedure with Docker, is once you've identified that there is an error somewhere, going inside of the container in order to resolve the error. In this upcoming homework assignments that you'll have related to Instagram, you're going to have a lot more errors like this as you're working on things. And so you'll need good debugging tools and habits in order to fix those sorts of errors. And one other thing I noticed is that people were just making lots of random changes to your Docker file, hoping that that fixed your errors without having a good solid step-by-step procedure of how to work through those errors. And this is a good step-by-step procedure that you will find useful in your upcoming homework. So again, what I've done so far is we've identified there was an error, and in order to resolve this error, I've entered into a Docker container starting at the image that was created just before the error happened. In order to help now fix this error, I'm going to run the command up here that was actually the breaking command. So if I rerun this in the image like this, this should be exactly identical to having done the Docker build up here, because Docker build runs this command. And so we can see that we get this same error message down here about things breaking. And so now I can try to, inside of my Docker container here, do what I need to do to fix it. And then once I've identified what to do to fix it, then I can go back and make the appropriate changes to my project. In this case, the problem is that, so we can see here, we're downloading a bunch of packages, and we get to this IO error inside of this package, workzug. Workzug is a package that Flask depends on. Flask is the package that we're using in order to create our web service here. And so the problem is in this workzug package. It turns out that this Docker file or this project was not created very well. And I'm going to enter this requirements.txt file in order to explain why. On the top window inside of Vim, I'm going to open a new tab by typing :tab E and then the requirements.txt file. Notice again that I did tab completion. Basically, anywhere in the terminal where you're typing in a file name, tab completion is going to do what you would hope it would do. So including in Vim right here, I do tab completion whenever I'm trying to open a file. And because I use the :tab E command, you can see that I have two tabs over here, and I can press GT in order to switch between the tabs. So lowercase g, lowercase t. And again, with Vim, all of these commands are not things that you type in at the same time, but they are things that you type in one after the other. And we can see that so what's the purpose of this requirements.txt file? This file, again, tells us what are all of the libraries that we need in order to install our current software. And they have specified that Flask 0.10.1 is the version of Flask that they want to use. Unfortunately, Flask depends on many other libraries, including this workzug library right down here, and they did not specify the version of workzug down here. And so we're getting an error message because they're using a version of workzug that is not compatible with everything else in this project. Why is this not compatible? Well, it turns out that inside of this Docker image, the version of Python that's being used is Python 2.7, and Python 2.7 is old, it's deprecated, it's been deprecated for about a decade now. And so workzug, this library, in their newer versions have decided that they're not going to support Python 2.7 anymore. And so it's getting this error message because we're using a bad version of Python, incompatible with workzug. Multiple ways that we could go about fixing this. One is that we could change our program to start using Python 3 instead of Python 2. In order to do that, inside of Ubuntu, anytime we reference Python, we can change to Python 3 by just adding a 3 at the end and doing something like this. And this will install Python 3 instead of Python 2. That would be an acceptable way to fix this program, getting it to work. To me, that seems like a very complicated, big change because, and it's likely to break other things in the project. And so that's not going to be the route that I'm going to take right here. Instead, what I'm going to do is I'm going to change the library versions that we're using down here in order to get library versions that work. And in order to do that, I can see that Flask right here is requiring workzug greater than or equal to 0.7, but it's downloading version 3.0.1. And so I will workzug equals 0.7 like this. You can pin the library version like this, and now this still satisfies the requirement of greater than or equal to 0.7, but and so hopefully this version will actually work. You notice that I've made the change up here in requirements.txt so that we could see it. But in order to actually verify that this version of workzug is going to work, down here in the terminal, I will type pip install work Zug equals 0.7 and verify that that actually works and is able to install, and it was able to install, and now we didn't get any errors. So now I can go back and try to reinstall Flask 0.10.1 like this. And we still get an error message, but now it's a different error message, no longer on WorkZug, now it's on markup safe. And so I can try to do pip install markup safe like that, equals to whatever the version number was up here that it's saying that it wants to get, markup safe greater than or equal to 2.0, but it's downloading 2.1.5. So let's do equals 2.0 like this, and successfully installed that version of markup safe. And now let's try doing the Flask equals 0.10.1. Uh-oh, still getting an error. And so we'll have to, in order to resolve this problem, keep going back and forth, getting all of these problems fixed until there's no more problems with the libraries. In the I'm gonna type exit down here to leave out of my Docker environment and go back to the Lambda server. So exit down here, and now I'm back in the Lambda server. If I type ls-a, you can see that there were a handful of hidden files down here in my Lambda server. And one of these hidden files is .requirements.txt.fixed. This is, if I do cat.requirements.txt.fixed, this contains a working set of dependencies. There are many other possibilities that you could use in order to get this built, but I will just use this set of dependencies real quick. And I will move my existing requirements.txt to .original, and then move the fixed version to the existing spot like this. So now if I have this requirements.txt, we can see here's the new version, all fixed. And up here in my requirements.txt inside of Vim, you can see that, so I just changed this requirements.txt file. It did not change the contents that's being displayed up here in Vim. In order for Vim to reload a file, I can type up here :E. E is short for edit. It'll reload that file. And now I can see that here's the changes that we actually made to our requirements.txt file. Down here now, if I type docker build dot, that should build everything now without any error messages. Successfully built all of that, and so now I could do something like docker run -it, this expression right here, that hash, and it will load up the web server. And at this point, you'd have to do all of the port forwarding and whatnot like we did in the lab in order to connect here. So again, there's a rundown of my way of solving the homework in order to get things, get working requirements up here that will actually build today. And I recommend you do a procedure like that to get your homework running for this week. And you will definitely have to do procedures like this for the upcoming homework. And the main tool for debugging, the thing that you want to remember is that when you get an error message in your Docker Compose file, a good way to debug that. So up here, scroll up until we were getting this error message. We were getting an error message right here in my Docker Compose file. The way to debug that is to find a working version of the image that was just above the spot where we had error messages. Use docker run to get inside this version of the image right here, and then we can manually type in commands into the container until we find a set of commands that works, or a set of requirements that works. And once we have that working set of requirements, we can adjust our project accordingly and rebuild the container to get it to work. That general procedure is going to be much faster than just trying to randomly change things in your Docker file and in your project until things start working. Any questions so far? Yes, Ben.
Do you mind explaining again why it's better to use all these older dependencies instead of just using type library?
Yeah, great question. So the question is that at one point I said that we have multiple strategies that we could go through in order to fix this problem. One is that, and maybe I'll back up for a second here. The fundamental reason we were getting this error down here is that this new version of this WorkZug package had deprecated Python 2.7 support and required Python 3 in order to work. And the question, or there's two strategies that we can use to fix that. One is we could switch from Python 2 to Python 3. The other is that we could use an older version of these packages that work with Python 2.7. And I suggested that using Python 3 is like a really big change to a project, something that, and so I didn't want to go that route. Why is that a really big change? Well, going from Python 2 to Python 3 is maybe going to fix this package right here, but maybe it's going to break a lot of other things. So up here in my Vim window, I'm going to type :tab-E and look at the app.py file for a second. And here, this version of app.py, like it's importing Flask up here, it's doing some things with Flask, and all the things it's doing is relatively simple. But we know that this version of this app.py file worked with Flask 0.10.1. And it turns out that if we were to upgrade Flask, or sorry, if we were to upgrade Python, Python 3 would not work with this version of Flask, for example. And so then we would have to update things in our code to make this work with the latest versions of Flask. It's a little bit of a sort of black art to know what sort of changes to make are going to be the most minimal changes to a project. But in general, changing versions of libraries is going to be a much smaller change overall, much easier to do than changing versions of programs, especially programming language programs. Yeah, so good question. Probably doesn't fully answer it, but that's the general idea. Oliver?
You explained the requirements.txt.fix file. Was that only created after you did like the trial and error implementation to find packages, or was that already?
Yeah, so the question is that inside of this, so currently in my Flask web folder right here, and at the very beginning of this demo, I typed LLS. We did not have, or the only three files that we saw were these three files right here. And later on, I did ls-a like this, and we saw that there was a hidden file that was like .requirements.txt. And if we come back over to the GitHub page right here in Flask Web, you can see that there is this .requirements.txt.fix file inside of the Flask Web folder. So there's a file that I've ended up giving to you. And this is a file that I created manually by going through this step-by-step process of manually trying to install the different packages until I found a version of packages that worked. And after I found a version of packages that worked, I created a new version of the requirements.txt that contained this new set of packages. So this is not something that was contained inside of the tutorial in any way. This is something that I had to create manually by myself. In general, if you are creating a project like this, you want to have all of the libraries that your project depends on inside of requirements.txt, and not just some of those libraries that your project depends on. The standard way in Python, in order to create one of these requirements.txt files, in order to show that, I'm going to go inside of the Docker container again. Let's do Docker PS. There is nothing running, so Control R, run. This will go back inside the container like this. I'm here. This again is running in the foreground because there is no -d on this run command. Again, the -d stands for daemon, so this is running in the foreground. So now that I've connected to this Docker container, I can't type commands in the command line because I'm not in the command line. I'm inside of Python right now. Why am I inside of Python? Because in this Docker file, the very last lines down here, this entry point, this is the command that gets run when you do the Docker run, and it's running Python on this app.py file down here. And so I'm not actually inside, or I'm not in a terminal, I'm not in a shell on the container down here. And so I can't run my bash commands that I want to run down here. In order to connect to this, I'm going to, up here in my Vim window, press Control Z to send that Vim window to the background. And now I will do Docker exec-it. So again, the difference between exec and run is that run creates the container from scratch. Exec connects to an existing running container and runs a command. In this case, I will run the command bash like this. Whoops, no, this is the image right here, not the container ID. I run docker ps like this. This is my container ID, docker exec-it, then the container ID hash over here, then bash like this. And now I'm connected. Both of these two terminals are currently connected to the container. Up in the bottom, it is actually running the web server. We can see the output of the web server. On the top, it is not running the web server, it's running bash, and so I can type in commands like this. The standard way, the reason I was doing all this was to show what is the way of generating one of these requirements.txt files. And the answer is with the pip freeze command like this. You run pip freeze, and it will tell you all of the versions of all of the libraries that you have installed. And you can do something like pip freeze, then output redirection into like requirements.txt, and that will create the requirements.txt file for you from the things that you currently have installed. So these requirements.txt files are basically never created manually. If you're creating them manually, then you're doing something wrong. You want to have the computer do it for you so you get the exact versions that you need. Did that answer your question somewhere in all that?
Yeah, I guess just to follow up to that.
Sure.
When you're doing like the trial and error to determine the correct packages, is this a sequential thing? Like you need to, you know what I mean?
Yeah, so the question is a little bit into this like trial and error, and it's really just an art about like what to know what sort of things to try. I used a fairly sequential procedure of I just found an error and I did the most immediate thing that I could think of in order to fix the error. In this case, the error is that this version of this package is not acceptable. So let's find an older version of this package that might be acceptable. In general, you could have more complicated things that you have to do. Good question. So, Henry.
So if we approached it, changing it to Python 3 like homework, that's not necessarily wrong, and will we need to use it that way when we like alter the project?
Yeah, great question. So the question is that in this sort of demo right here, stuck with Python 2. What if you change things to Python 3 instead of Python 2? Is that acceptable? And the answer is yes, 100% acceptable. If you did that and you got things working, then there's no need to resubmit or try to fix things. In general, for this class, as long as you get things working, then you're good. And I don't care about like which path you take in order to get things working. This tutorial used Python 2. Everything else in this class in the future will always be Python 3 though. One of the reasons why I selected this tutorial in order to make you go through it is just so that you have this awful experience of fighting against Python 2 and 3 at some point in your life. Good question. Yes?
This is related to Python versus
Sure.
library. What I did was initially I just that I downloaded the latest of the library afterwards. But I don't know which one's like for it.
Yeah, so in terms of intuitive, like that's going to be differ from person to person, and like which techniques can be the most intuitive. So here we have a project that was relatively small, and so like what sort of changes you make were you could get to a working solution basically through many different paths. You could imagine though that like if this was Instagram's code, Instagram has hundreds of millions of lines of Python code at this point running their web servers, and upgrading that amount of code from one version of Python to another version of Python is going to be a tremendous effort. So as the code base gets bigger, different paths of fixing these problems become less realistic. But again, for the purpose of this class, whatever worked for you is great. Yes. Yeah, this is a great question. So the question is, down here in Docker run, we have this IP address down here, and questions about some more details about this IP address. I'm going to type FG on my top window in order to bring back Vim, and I'm going to press GT to go to this app window, and Shift G to take me to the bottom line of my app.py. And here in this app.run, you can see there's this host equals 0.0.0. And so the literal answer of where this comes from is that it comes from this location here in our app.py about what the host value over here is going to be. The default port value is 5,000 for Flask, and so 5,000, there is another parameter like this. You can do port equals something else in order to change it, but there's no need to do that. If we were running directly on the Lambda server, then port 5000 is already taken on the Lambda server, but we're not running on the Lambda server. We're running inside of a container. A container is a totally different machine with different ports available to it. And so there is no conflict with the container using port 5000 or all of your different containers using port 5000 because they're different machines. So why is this using 0.0.0.0? This is a sort of a special IP address. If this were a networking class, we would go into detail about why this is a special IP address. But it basically means that anybody is allowed to connect to this, this port right here. This IP address here is not only, like when you're typing something in Firefox, this is what IP addresses you're connecting to. When you see something down here, this is more like what IP addresses you're connecting from. And so it's very common to have a web server that is on IP 0000. Down here, or up in my Vim window up here, I'm going to do Control Z to come back to my terminal. I'm inside of the Lambda server right now. If I type host name, you can see that host name will give you the name of the server that you're currently on. So host name inside of the Lambda server. And if I were to do something like curl http localhost 5000 like this, this is not this web page down here. This is my my existing 5000 web page, and but this has to be localhost when you connect to it. I'll do a demo of the connecting with the ports here real quick. So if I do Docker PS like this, so here's my container ID. Let's bring this down. Docker stop D70, enter. No container D70F. And Docker PS, not running anymore. You can see down here it actually quit. Let's do down here Control R to bring up my run command like this, and add the -p. We'll do 2345:5000. This will map the, maybe it needs to come first. -p 2345:5000 like this. This maps port 5000 on the container to port 2345 on the Lambda server. And now up here, my curl command, Control R, curl over here, change the 5000 to 2345 like this. And we get the results of the connecting to the container instead of the existing web server. And you can see down here that every time I connect, we get a little message down here from the server saying where exactly we connected to in the HTTP status code down here. Somebody else is connected as well. Good job. Up here, let's see, I'll just do a quick explanation of these status codes and this get command. Curl or links, whatever web server you're using, says get, and then the URL on the web server that you're trying to get. Here, this command is like / over here, but I could have something like maybe test.html that I'm connecting to, and hit enter. And so you can see down here, test.html. That doesn't exist on the web server, so we're getting this 404 error message down here. 200 means that this URL existed. 404 means that this URL did not exist. Forget what the original question was, but did that answer it somewhere? Cool. All great questions. Okay, today in class, So what we're going to do next is we're going to see, well, let's see. Down here, press Control-C to leave my web server real quick. And here we see that this Docker run command is starting to get like kind of complicated and obnoxious to run because I'm having to specify ports. I'm having to keep track of weird hash values. I'm having to keep track of many different Docker commands all at once in order to build things. Today in class, we're going to start talking about this system called Docker Compose, which is a tool for automating running of Docker commands for us. Tool for automating Docker commands. So you won't have to, after you understand Docker Compose, you won't have to deal with these like long, complicated Docker commands anymore. And we're also going to, once we start talking about Docker Compose, introduce a handful of other features about Docker, and we won't have to get into super complicated commands for that because it'll all be inside of Docker Compose. Before we get to that, I want to make sure that I cover a few more announcements in class, though. Oops. Back at the topic 3 web folder. So any questions about anything about the homework before I get to the next announcement section? Okay. So we've made it up to here so far. Takeaways from this homework. Getting versions right is really hard. The best solution we have is hard coding these versions, which we saw how to do with this pip freeze command. That works for Python, but it doesn't work for other things. All the different types of libraries that you're using will have their own different tools for doing this. What's the downside of hard coding these versions is that it leaves you open to security vulnerabilities. So like Flask 1.10.1, for example, is a very old version of Flask. It has a number of security vulnerabilities inside of it at this point. And if somebody knows that we're using this old version of Flask, they could take over our web server. So it turns out that in deployed Docker images, I'll let you read through these links if you want. Most deployed Docker images have critical security flaws in them that allow people to take over their systems. Major companies like Apple, Microsoft, all of the companies that you've heard of before have been hacked in the past because of developers using older versions of software that are no longer fixed. So this is a very common way of being able to take over machines at companies and hack companies. One of the tools that we have for helping solve this is something called semantic versioning. This link over here takes us to semantic versioning. It is traditional that all Python packages should follow semantic versioning. 90% of other systems follow semantic versioning, but not everything does. The key idea of semantic versioning is that all versions will have 3 numbers like this. So here this is version 2.0.0 of this document. The leftmost version number over here, this is called the major version. This number right here, the middle version, is called the minor version. And the last number over here is called the patch version. And semantic versioning allows us to provide an upper bound on versions that work for us and not just fixed versions. So previously we saw that Flask required workzug in their requirements.txt greater than or equal to 0.7, but they had no upper bound on their version number, and so eventually workzug, the new version, was not backwards compatible. But if they had also provided an upper bound of something like this and workzug less than or equal, strictly less than 1.0.0, then we would never get a workzug version that was a new major release. It would always stay as only minor releases or patch releases. And the convention, there's nothing mechanically enforcing this convention, but the convention is that minor releases will never be backwards incompatible. So it's always okay to use a new minor release or a new patch release, but it's rarely okay to use a new major release. So some companies, instead of using the fixed versions, will try to follow semantic versioning in order to to fix things. But that introduces its own problems. And so in general, major companies will have developers or employees whose title is DevOps, and their job is to deal with all of these sorts of problems. DevOps stands for developer operations, and it's sort of the people who sit in the middle of the people writing the code and the people deploying the code. Let's see. Yeah, we'll go over this. So how does homework, we'll do a little bit more soft stuff before getting to our more technical new stuff for today. How does this homework from last week and this week relate to your career stuff? Have a career.md file in our repository where I have some notes about career stuff. Do I have it open? I don't have it open. So here's career.md. So in my opinion, it's actually a really good time at this point to be sort of a mid or senior level programmer, and it's still an average time to be entry level. I know many of you are looking for jobs right now, and so you feel like it's an awful time to be an entry level person because looking for new jobs is always really hard. And you hear a lot of like bad things about the economy right now, but it's actually pretty average right now for getting new jobs. It's just always hard to get new jobs. If you were interested in tracking layoffs, there's this layoffs.fyi website. Turns out that it's mostly non-technical people at companies like Google that are being laid off. It's a lot of HR people. So you can visit these websites if you're interested in that. If you're interested in just seeing like how many employees there are at companies, so here's tracking like Microsoft, or this one's Google maybe, employees over time. They've gone down from last year a little bit, but again, that's not because of engineers being fired. That's because of the more HR sort of people being fired. Companies like Microsoft just growing less than they were growing in the past. In the COVID years, all of these companies seeing like very, very high growth, and now just sort of leveling off. Originally talking about all of this because we mentioned this new DevOps sort of position. How does that relate to these other positions? So a data scientist, sort of somebody who's going to be using the DevOps stuff. DevOps, somebody who's connecting the stuff that software engineers are developing into production. If you want to see about like the salaries of the different jobs, levels.fyi, famous website for doing that. Yeah, that's all I want to say about that. The homework for this week is already posted below, so you're welcome to get started on it. My recommendation is that before the lab is also already posted. Before our lab class on Friday, there are that you start working on the homework, and the homework has 2 sections inside of it that you should do before the lab. So doing this project setup right here and this Docker section right here, do those before the lab. And then during the lab session, we'll do this Postgres session together and see sort of all of the sharp edges that you can encounter in this homework. So in order to be prepared for that, do these 2 sections before Friday, and then again, Friday in class, we'll be doing this section together. One last thing I'll say before technical stuff is that this homework is one that, so again, what you're doing in this homework is you're building an Instagram clone, and this is one that students, after having completed it and they go on and get their jobs, graduate, come back and talk to me, they always say that this is like has been the most helpful homework of their career, because it goes through basically end to end, going from nothing to having a full working like backend for a startup that you might want to work on. So this is hopefully a fun homework. It's also, you should expect it to take a lot of time. Here I wrote, expect to spend at least 10 times the amount of time on this homework as you did on last week's homework, because it's longer, more sharp edges, and if everything works perfectly for you the first time through, you could finish it reasonably in under an hour, but probably everything won't work perfectly reasonable, and you'll have lots of weird things that you'll have to debug, and so expect to spend a lot of time debugging that. Any questions on anything administrative? Okay. On to the fun stuff, technical stuff. So back over here to my two terminals, reset them both so we have nice, clean working environments. And what we're going to do is, again, we'll introduce this idea of Docker Compose, this new tool, and we'll see how it simplifies many things in our life related to Docker. Docker Compose is a Python program, and so in order to get access to it, you'll need to install it, pip3 install Docker Compose like this. And if everything works successfully for you, then you should be able to run Docker Compose, and it will not give you an error message. You'll just get a whole bunch of help output. If you get an error message, if you get an error when running Docker Compose, then it means that you did not install successfully. You didn't install it. There is a system-wide Docker Compose available, but I've disabled it for you because it's an older version, and so you want to make sure that you're using the latest version that you get when you do pip install. We saw last time that in order to use Docker, we need a file called Dockerfile, and in order to use Docker Compose, we'll need a file called Docker Compose, like this. The Docker Compose file has an extension .yml. This is pronounced YAML, so this is the Docker Compose.yaml file that we are editing. And YAML files are a common configuration format. If you've looked at all in the GitHub Actions files from some of the previous homeworks, they're all GitHub Actions also uses YAML for its configuration. So I'm creating this new Docker Compose.yaml file. They always start with a version up here. 3.7 is the version that the tutorial is using, so we'll just stick with that for now. And then there's a section services, which defines all of the services. The way of thinking about a service, you think about a service as a container. They're sort of equivalent to each other, or as a machine that is running as part of your product, or a machine that is running as part of your project. In this case, we only have one service. We have the service that is providing the web page for us, so I'll call it web like this. But in general, we could have many more services, and in your homework, you'll have at least 4 of these services, potentially more. So we'll create a web service, and then the simplest possible Docker Compose file looks like this, where we specify the build folder of what we're building, and the dot specifying the current folder. So the build, this should be the location where the Docker file is. And currently we're just inside of our current folder, so dots. Down here, run Docker, let's see, run ls. We can see that we now have this Docker Compose file, and instead of doing Docker build, instead of doing something like Docker build dot, we can do Docker Compose. Notice also, so I use tab completion right there. Tab completion works not only for file names, it also works for command names. And so I was having problems typing in my command name because I was not being sufficiently lazy, taking advantage of my tab completion. And so I'll do that to type in Docker Compose like this. And Docker Compose build runs the Docker command for all of these different services. In this case, again, we only have one service, which is the web service right here. This case, services version must be a mapping, not a string. Let's see, it looks like I have a typo in my config file right here. So what I'm going to do is I also, as a backup, have a working Docker Compose file in as a hidden file right here, .docker compose. Up here in my Vim, I'll do :tab .docker compose to take a look at that. Version is supposed to be lowercase, so is services. So over here, version, services, make those both lowercase and come down here and rerun it. And you can see that the output down here now looks like what the output of a build command would have looked like. You can see down here where it says successfully tagged. This is the only line in the output that should be different than running the docker build dot command, docker build dot. The only line that's different is this line down here. This is giving us a name of our image so that we don't have to use the hash. So I think in the tutorial you use the -t command to name your image. We don't have to memorize those arcane sort of flags like this anymore to name our images. We just get this as our name. The format of the name is always your current working folder. So pwd, the last folder here is Flask Web. So it's sort of like my project name is Flask Web, and then underscore, and then the service. So it's Flask Web underscore web, because I have a service called web right here. Any questions so far? Yes. This command? Yeah. Yeah, so Docker Compose, like Docker, has a number of commands associated with it. They'll always be Docker Compose and then like the command that you're trying to do. And most of those follow the same pattern as Docker. So because we were sort of previously doing Docker build dot, this Docker Compose build does the same thing as Docker build dot. And the idea is that Docker Compose, whatever we have here, is the same. I'll write it out. That does the same thing as Docker build. So this command here matches this command over here, but we won't have to provide all the weird flags. Those weird flags will be provided for us inside the Docker Compose.yaml file, so we don't have to memorize them. Good question. Any other questions so far? Yes. Yeah, the question is, so if you've used C before, especially, or C++, there's a special file called a makefile. We'll actually be encountering those later in this class. Makefile describes your project and everything that goes into building that project. And the question is Docker Compose like a makefile? And the answer is they're very, very similar. They both describe what to do to build a project, and so very similar. Good question. Okay. So the next thing we'll do with Docker Compose up here is we'll see how to use ports for us automatically. So we can have this field ports like this, and that will make us, so we don't have to specify this -p flag, just like the web up here. This is like -t web. The ports is something like this. That is like -p 2345:5000. In this case, because we're using Flask as our web server right here, the thing on the right should be 5000 because inside of the container, we are on port 5000. And the thing on the left over here will be what the port we're opening on the Lambda server. In general, the sort of mnemonic, anytime you're like having to connect two things together, is the thing on the left is closest to you somehow. Closest to you, and the thing on the right is farthest from you, farthest from you. So here, this is connecting the container to the Lambda server, connecting the container to the machine that the container is being run on. And so the thing that is farthest away from us is the container, and the thing that is closest to us is the machine that's being run on, the Lambda server. And so that's why the thing on the left is the Lambda server, and the thing on the right, the container. Come down here, let's do another Docker build, and Docker Compose build, and we get an error message over here, invalid type, it should be an array. This is a annoying thing about YAML files. Many annoying things about YAML files. YAML files are very controversial when formatting. If you see something about an error saying something should be an array, in YAML, an array is lines on by itself that start with a dot. So this indicates an array, and ports should be an array because it needs to be like a list of what ports are getting connected to what thing. In the build over here, you can only have one folder that you are building from because you can only have one Docker file. But ports, you could potentially be connecting many ports to many other ports, and so it needs to be this array, and you have to use the dash like this to indicate that this is an array. You can create multiple entries like this, so 2, 3, 4, 6 to 5001. This will connect now this port to this port as well. We happen to not be using this port, but that's fine to connect in multiple locations. And so that's why we're getting this error about an array. If on the homework you're getting an errors about arrays, the thing to check is that you probably just forgot to format your YAML file in this way. So let's save that, come down here, up arrow, rerun, and now no problems down here. If I run Docker PS, you can see that we don't have any containers running because all I did was do Docker build. If I want to actually have the containers running, then I can do Docker compose up, and this will run all of the services. Docker compose up is like doing Docker run on every service. And here, the ports, this is going to affect the run command or the up command. It doesn't really affect the building process. Come down here and hit enter. And now you can see here's the same output that we were getting before from our Docker run command. But we didn't have to manually type in all of that stuff. We didn't have to remember what was the hash of or the name of our container. All we had to do is do Docker compose up, and it does all this stuff for us. One last thing before I pause here, I'm going to do Control-Z in my top window up here so that I can verify that things are running in the bottom. And in the top window, I'm going to do Docker PS. To see the output down here, we can now see that there is, in fact, one container running here. And if we looked through the output of all this, we would verify that the hash matches. So here we go. The name of it, the Flask web right here, comes from this name right here. And this is our new container ID. In this ports section over here, it's a little bit hard to see with the screen wrapping lines around, so I'm going to zoom out really quick. In this ports section, you can see all the lists of ports that are being mapped. And so you can see here that like 2345 is mapped to 5000, 2346 is mapped to 5001, listed under this ports section right here on this container. And that verifies that our Docker compose file did in fact do that port mapping. You can see that this is, it actually lists both of these port mappings twice. The one on the left here is IP version 4. The one on the right here is IP version 6, or TCP version 6. IP version 6. And you can see this 0.0.0 again coming up, meaning that anybody is allowed to access this 2345 port right here. Okay, any questions so far? Yes, Henry.
Could we pull the port forward the same, like could you port forward 5000 to 2345 and 2346?
Question is, in the Docker file, can we have one port that is going to multiple locations over here? And the answer is that I believe so, but you would basically never want to do that. So it's, we're computer scientists. Let's run an experiment to verify this. Control-Z, change that. Docker compose down. So down brings the service down. Whenever you change the Docker compose file, you do not have to rebuild. So down here, changing Docker compose.yaml, don't have to rebuild because all we've done is change the port flag, and the port flag is something that affects the Docker run command. So all you have to do is bring it down and then bring it back up. Docker compose up like this. And so it is saying that it's encountering errors while bringing up the project. And so it does not want us to be able to do that. And so now if we make that change, bring it back up, then we won't have those errors. In general, yeah, there's no, it's not the Linux kernel that's stopping us from doing this. We would be able to do this if we wanted to, but Docker Compose has this just sort of safety check built in that's preventing you from doing that because it's not something that ever makes sense to actually do. A good question. Yes, Nico. Question is, over here I have 5,000, and why is it 5,000, and can we do something else? The answer is yes, you can do something else. You can do whatever you want over here, and Docker will not complain. Docker will happily map whatever you put over here to whatever you put over here. But the reason I chose 5,000 is because, again, in my app.py file, this is the file that is creating the web service. The web service is being run on port 5,000. So the container has a service on it being run at port 5,000. Your app.run is not passing in this port flag right here because this is the default value for the port command right here. But this right here, this 5,000 must match whatever's in your Docker Compose over here in order for the routing to take place and for you to be able to access your service on this port over here on the Lambda server. If you were changing your port for whatever reason, so this instead of 5,000, you could make this 8080 like this, in which case you would have to make this up here also 8080 in order for it to work. On your upcoming Instagram assignment, you will be having a fairly complicated routing system where the thing on the right over here will not be 5,000 anymore because for various complicated reasons that you'll see in the tutorial. But so you'll have to be careful about making sure that this thing on the right always matches the container and this thing on the left matches the Lambda server. Good question. Yes, Emma. Question is, why did I select 2, 3, 4, 5 over here? And the answer is it was just totally arbitrary. I just typed in whatever number I came to my mind quickly. On your homework assignment, I recommended using your user ID just to ensure that you didn't have a collision with somebody else. But there's no requirement that you use your user ID. If you were to have a collision with somebody, so 5,000 I know is already being used on the Lambda server, press Control-C, up arrow, you'll get an error message where the error message looks something like bind address already in use. In order to, anytime you see an error with this bind address already in use, that means your port over here on the left-hand side is already being used by somebody. And so in order to fix that, it must be a unique port over here. And one way of getting a unique port is that if everybody used their user ID, but you could also, it doesn't matter what you use here, as long as it's unique. There's one last thing I want us to cover for today, so I'm gonna pause questions for a second, and we're gonna talk about volumes in Docker. So one of the things that we've seen so far is that Docker containers are ephemeral, which means that whatever changes you make to a file inside of the container is going to stay in that container. And as soon as that container comes down, as soon as you do something like Docker Compose down, bringing that container down, that will delete whatever changes you made to that container. If you're Instagram, though, and Instagram goes down for a little bit, you don't want all of the user data to be gone forever. So we don't want all of our data to be ephemeral. And volumes are how we get non-ephemeral data. Non-ephemeral data. So non-ephemeral data, meaning the data stays around. Data stays around. Next time in class and during the lab, we'll talk about these volumes in more detail. So we're just doing a superficial overview right now. But this is going to be like a very, very key concept for us, especially as we focus on data science issues, because we care about our data. We don't want it to disappear when the Docker container goes down. In a Docker volume, the syntax for this is going to be very similar up here, where we're going to connect a folder on the Lambda server to a folder inside of the Docker container. So we'll be doing something like ::, and then /app. I have a colon here separating a location on the Lambda server to a location in the container here. The dot, again, refers to our current working folder, and the location over here, /app, is going to be the location on the Lambda server. And this is going to say that everything that is on our current location dot will be mapped instantly over to our this /app folder on the Lambda server. I will do Docker compose, spelling it correctly or using tab completion to be even better, up like this. Now we have this volume created. There we go. Everything worked well. And up here, Control Z, type ls right here. And let's do a one of those exec commands. So I'll do now Docker compose exec and the name of the service that I want to connect to. I don't need to look up the hash or anything when I use Docker compose like I did with just Docker. And I want to exec the bash command. And now I'm inside of this folder over here. Or sorry, inside of this container that we're connected to down here. Both of these terminals connected to the same container. And I'm in this /app folder. Type ls, and we can see that the contents of this /app folder exactly matches the contents of the /app folder, or of the dot folder, the root folder of my project on the Lambda server. If I do touch hello-world right here, type ls, we can see that we've created this hello world file inside of this /app folder, again, on the Docker container. But if I type exit right here and type ls, you can now see that this hello world file was created on the Lambda server as well. So this file on the Lambda server is exactly connected, or this folder exactly mapped over to the same location on the container. And the way we did that, again, with this volume right here, this is the location on the Lambda server, this is the location on the container. Next time in class, we'll go into more applications about why you'd want to do this with these volumes, and we'll see that a lot more again in your homework. This is a good stopping point for us today. If anybody has questions about any of these things or anything else in the class, happy to stick around and get those answered. Otherwise, I will see you all on Thursday. And reminder, we have the quiz on Thursday about the Git stuff. So good luck studying for that.
I'm just having trouble uploading a PNG onto my GitHub repo, and I'm gonna definitely be able to. I was trying to fix it, but I have to fix it.